Good day, my name is Raymond Fourie and I'm a junior process engineer working at our Multotec research and development facility. Today I will be presenting on the fines processing in the mineral sands industry and our development of a spiral to satisfy that processing needs. So a bit about what I'll be presenting about. The presentation includes some background on why a new spiral is needed, our plan to develop this spiral, some results to compare the existing heavy mineral spiral with the new spiral, what utilizing a diverter, or in other words a repulper, will give in terms of recovery of economic heavy minerals, and how it compares without utilizing that repulper. I will also be talking on a summative results based on all the phases, which I'll elaborate on shortly, and then further developments on this new spiral. So why is a new spiral needed? Well, in the mineral sands industry, spirals are used for the pre-concentration of low-grade heavy minerals, typically with a feed between 0.5 to 15% heavy minerals. In wet concentration plants, the requirements are to recover as much of the heavy minerals as possible, with concentrate recoveries ranging between 85 and 95%, and in turn so minimizing the gangue that reports to the concentrate. Challenges seen in heavy minerals processing is that the spiral is not selective. Some gangue in heavy minerals concentrate is dense, thus meaning both the economic heavy minerals and gangue heavy minerals report to the concentrate fraction. So this brings us to our spiral development plan. In short, this is our development plan, ranging from phase 0 to phase 3. In phase 0, we've tested our existing heavy mineral spiral to obtain a baseline to compare the other phases with. In phase 1, we brought about a profile change, whereas in phase 2, we've utilized that profile change together with other changes to obtain this new 117HM spiral. So in phase 2, we've tested this new spiral without a diverter, or a repulper in other words, and then in phase 3, we've tested it with a diverter. So what does the result say regarding all the phases? We've tested all the phases at 45 and 55% solids with a sample with a feed EHM of between 0.5 to 1%. Now, what I want to show in this table is the recovery of economic heavy minerals to the concentrate fractions. Now, if we look at 45% solids in phase 0, we were sitting at around 45% recovery. In phase 1, 66%, and then in phase 2, around 55% recovery. Now let's look at the 55% solids results. If we look at phase 0, we are sitting at around 36%. In phase 1, around 52% recovery, and then in phase 2, around 62% recovery. So here we see a different trend. It steadily increases over all the phases. What I also want to show is the grade of the economic heavy minerals to the concentrate. Now, if we look at 45% solids, we can see it decreases over all the phases. Now, at 55% solids, it follows the same trend. For instance, at phase 0, we are sitting at around 47%. Phase 1, 36%, and then phase 2, 10%. So here we must remember that there is always a compromise between grade and recovery. So if we increase in the recovery, we are compromising some of that grade. Now, we've tested this spiral for the rougher application. So that's why we've decided to take the concentrate and middlings as the final product. So if we look at the economic heavy minerals recovery to these fractions at 45% solids, phase 0, 60% recovery, in phase 1, 78% recovery, and then in phase 2 around 75% recovery. Now if we look at 55% solids, we see a different trend here. In phase 0 we had around 73%, In phase 1 it went down to 65%, and then ultimately in phase 2 we've obtained 84% recovery, meaning that we've recovered close to the specified 85%, which is one step in the right direction. So what happens when we utilize a repulper on this new spiral? We wanted to increase the recovery even more, so we've utilized a repulper or diverter in 3 different positions on this new 117HM spiral, where you can see position 1 was the least aggressive position, position 2 was moderately aggressive, and then position 3 was the most aggressive position. So let's look at the results. What I want to show in this table is the recovery of the economic heavy minerals to the concentrate fractions. So if we look at phase 3, where we've utilized that diverter, you can see for setting 1 we've recovered around 69% of that economic heavy minerals. And it steadily decreased as the splitter position became more aggressive. So ultimately it resulted that we've recovered the best for a diverter setting of 1. So that is the least aggressive position. Now comparing that to phase 2, we can see that we had a 24% increase in recovery. So this means that utilizing a diverter on the new 117HM spiral ultimately resulted in better recovery. As I stated previously, we've tested this spiral in a rougher application, so that's why we've taken the concentrate plus middlings as the final product. So this is just some summative results at 45% solids, just to see what the recovery was at each of the phases. So in phase 0 we had around 60% recovery, in phase 1 around 78% recovery of economic heavy minerals, in phase 2 75%, and then in phase 3 we had 84% recovery of the economic heavy minerals. So we've noted that with an increase in the recovery, we compromised some of the grade. So for further developments, we are looking into changes to improve the selectivity of the economic heavy minerals and to reject the silica to the tailings fractions. We're also testing the 117HM spiral with different mineral sand samples, which contains different feed economic heavy minerals grades. We're also testing a full flow sheet, which means we're testing the capability of the 117HM spiral as a rougher and scavenger in unison with a cleaner spiral. We are actively developing on this, and also we are remembering to celebrate the milestones as we prepare for the road ahead. Thank you.